Hello, everybody. How are you guys? Uh, okay, thank you for Space Apps actually from NASA to invite me actually to give you this type of presentation, which is like it's about the machine learning and data analysis because actually the things that I noticed like most the challenge that we have to go through, which is like analyzing some data, whether like it's gonna be like numerical or image or like any other. So nowadays, you know that machine learning nowadays become like let's say one of the popular mechanisms that's being used actually to analyze the data. We have to understand some tips or some points about the machine learning and data analysis, and in this way, which is like going to help us how we are going to like use our data and how we can like extract the information from our data, how we can like remove some spectrals or like let's say editing our images to have like let's say a clear image and a clear vision for our image. So just at the beginning, actually, some of us actually we are who keep telling that machine learning is doing that, the machine learning is doing that. So we have to know actually what is the machine learning from the beginning, actually, and we have to understand how is like the machine learning is gonna work. So we have to know that this machine learning is part of the AI, is not all of the AI, and it can be like let's say under the umbrella of the AI, which is like most is gonna be like combination of the data and statistical tools. So we have different type of tools, and we have to know how we are going to use actually what the type of the tools which is like going to be suitable for our like let's say our analyzing or our data analysis or what the type of the data as well. So not everything actually like in AI should be like let's say as a machine learning because the AI is the a huge cloud we can say or the huge space of different type of application that can be implemented like others such as like we have image processing, we have optimization, we have robotics, and we have different things. And machine learning is considered like, let's say, as a small part actually of the AI. So the idea from our presentation today, we're gonna talk about like, let's say, the machine learning and data analysis. And you have to understand that the machine learning, usually it depends like the way it's working, like how is our like our machine is gonna learn from the historical data or from the current data that we have it, and based on some feature they can likely say distinguish many things actually. So we have to understand what is the type of the data set as well. So what is likely say how does actually the machine learning it work? We have actually like two phases of the work of the like machine learning how it's work. Actually, we have to know that we have a learning phase, we have an inference from model phase. So we have two phases, and the learning phase actually with anything actually with the machine learning that we needed we should actually teach that machine. We should like give it the machine that some feature. We should give the machine. It's like we are like communicating with the machine, like we are working with a human being. How we are like let our machine to work as a human like that. How they are going to learn. So we're gonna start actually from the small kids until it become like let's say more knowledge. That in this way actually like the machine is working. So we keep give it like let's say as a training data. This training data most of the time it's gonna be like what you are thinking about actually, or like what is the data that you are going to analyze it, or what you wanna teach the machine how it's gonna predicting actually for your data. So we have actually like let's say the training data. The training data usually is gonna be inserted to the some including some features as well and in the vectors, and then the algorithm will understand how it's like when this feature is getting high and how it's going to be like low in the other features. So those things actually like we are teaching the machine, they can like let's say make the relation between each like let's say each rows in data or whatever actually. So after that we can give actually like let's say the inference model like from the model how we gonna check actually our code or our machine learning algorithm its work in this case. So by using like something it called like testing data, the testing data which is like it's gonna be like similar as the training data, but actually like let's say the machine it will not actually like let's say it will not like learn from this data. It will predict or create another data, which is like do the like let's say the comparison between the test data and what the data that's been created by the machine. And sometimes we have like let's say numbers like to check our machine learning that it's gonna work or not, which we call it like let's say the accuracy. The accuracy like is as much as like the accuracy is getting high, that means as much as like let's say our machine learning, our machine or our algorithm, it's learn more actually in this part. Another thing we should know actually, which is like about the machine learning. How is the machine learning actually like, what actually they are used? Most of the time when we are like looking for the machine learning algorithm, we should know actually what the type of the data that we are going to work with. And based on that, we can like let's say select whether like let's say we need to select like an unsupervised learning or like the supervised learning or like reinforcement learning. So in the machine learning, we have different type actually of the data, and we are not always having like let's say the same data or the same specification of the data, or like, because sometimes actually we are working with the data more than to work with the machine learning algorithm. We call it like something a cleansing, and then I will go to that part actually later. So we have to understand what is the difference, the most important two things actually between the supervised learning and what is the unsupervised learning. Because during our work, if we cannot determine actually like let's say we cannot label the feature or we cannot label the data, it will be considered like as unsupervised learning, especially like when we have like let's say a huge amount of data such as big data. So we're gonna work actually with the dimensionality reduction, such as that we're gonna work actually with the big data visualization in this case. If we have like let's say the supervised learning, we can go with the classification and regression, and for unsupervised learning, we're gonna go actually for clustering and dimensional education. And the reinforcement learning, which is like it's between the supervised and unsupervised, which like most of the like let's say most of the researchers, they prefer to work in the reinforcement learning in this case, because like we are not going to work that much actually on the data. That is why we prefer actually to reinforcement. So when you are starting your project, you need to think actually about the data that you are going to choose and to implement your like a data analysis in this part. And are you going to work with the data? You really need to understand the data. You really need to specify the feature for your data, which like is very important for you in this case. This case, it's allow you, or like I say, it guide you how you are going to choose the algorithm in the machine learning. And we have to know actually like there is different type of data can we work with. Another thing that I'm going to talk, which is like how is like the supervised learning it's working. So as what you see, like we have like different type of data. I have here like I said the simple example here, which is like I have like different color circle actually, like, and like we have the dark, we have the gray, and we have the blue. So those actually like it's labeled like this data. So the data, it will be like let's say divided in two parts. We call it like let's say training data and testing data. And the recommending of the dividing this part is going to be like 80 over 20. Like let's say 80% is going to be for training and 20% for it's going to be for testing data. This is actually the recommended in the literature. And when we use it actually, and when we insert it in the algorithm itself, and in the algorithm they will read actually the training data first, and then they will understand the feature, and then the algorithm, it will like let's say keep and learn from the training data with the labeled data. So this one, most of the time, as what we mentioned before, we are going to work actually in classification and in the regression, as well as what you see in this slide. So here, when we are working actually in classification or cluster or like regression, we have different type actually of algorithms, such as we have support vector machine, we have like let's say linear regression, multilinear regression, different type of algorithm that can be implemented. And just actually to be honest with you, the best thing actually when you want to actually start your working with this type of machine learning, you should actually start from the simple and you are going to grow up, because implementing that through different type of tools such as MATLAB, Python, whatever, there is an already library that you can import and implement it. So it will not take that much time actually while you are implementing this type of the algorithm. So the simplest and the easiest, it will be like sometimes it's much better, which is like based on the accuracy, you can like make the differentiation between of them. And during the process part, then the process part, they will likely say we have here part, for example, we have classifying. So we have classifying actually, like let's say the output in this way. So when we are classifying this part, actually, we can check actually like our code or our algorithm, how it's going to work, the performance of our algorithm based on the testing data. And we can see like make the comparison between the output and with the testing data. So we have in the training data and desired output based on our data, which we call like, let's say, the tested data. For the unsupervised learning, which is like, it's important actually to understand it here, because the data, there is not that much work actually on the data. You have to know that like there is no labeling and there is no, like let's say, any specific data, like a specific amount of data in this part. And one more thing, we have to understand that usually in the raw data, there is a lot of work should be worked on before we insert actually, or before we point it in the algorithm, because actually like the algorithm itself is going to work in the data, and in this case it will give it as a label, and based on that it will learn, and based on that will process, and then they will make, like let's say, the dividing between, like let's say, this type of the data. So we have to understand actually what is the data that we are going to work with actually, either is unsupervised or like unsupervised, and with the type of the algorithm, because like in the supervised and supervised learning and unsupervised learning, there is a specific algorithm for each part. So the most important question most of the time when we are implementing our code, or when we are implementing our machine learning on the data, when we want to do actually, like I say, the data analysis, just like how to select the machine learning algorithm. Since like we understand how's like the supervised and unsupervised, I'm going to provide for you actually, like let's say, an algorithm cheat sheet. Well, like what you are going to do first, you have to understand what you are going to do with the data, and then you can select the algorithm in this part. So what we are going to do actually, what to do with the algorithm, this is, I'm going to show you actually the cheat sheet. And here like we can like another additional requirement, which is like you're gonna, what you want to extract, and like let's say like the accuracy, the training time, the linearity, the number of the parameters, and let's say the number of the feature. Those is gonna be like, let's say, an additional to how you are going to choose the algorithm. So just I'm going to tell you actually about, like let's say, the accuracy, training time, so, and linearity, and number of parameters, and number of feature. So if you have, like let's say, the accuracy, you need, if you are like really learning on the accuracy to select the algorithm, so you need to work on the data, you need to work with the data. The data is very important to be cleaned from the, like let's say, redundancy, empty, like even thought like to fill up there's an empty data with the accurate part, like even thought you can, like let's say, we can do, like let's say, we call it like the pre-processing of the data, which like is very important. So in this case, you can, like let's say, have, like let's say, a high accuracy, or like based on the algorithm itself, or sometimes you need to add a feature to get the high accuracy, and even thought like the training time. Some algorithm, they will take time while, like let's say, while you are doing the training of your data, which is like, it will not actually help you, like if need, like for example, take like 2 days or 3 days, and there is like a lot of things inside the algorithm, especially like if it's have like a huge number of parameters, or like let's say a huge number of the iterations. So in this part actually, like we are taking in our consideration the time factor. It's gonna play a big role actually in our like in our project or in our program. So I'm going to show you actually what is the cheat sheet for the algorithm now, and which is like, it's very important to understand it, and you can look at to that part of the cheat sheet. Look at here, actually, the first thing what you are going to do, actually, what you want to do actually for the data. If you want, for example, if you need to extract an information from the text, you have to go to the text analysis, and you can see like there is a different type of algorithm, such as we have extract algorithm from feature from the text, we have the feature hashing, we have the pre-processing texting, word to vector, and there is a lot of algorithm that being related. Another thing we can use like a prediction value. A predict value is like I said, the simple machine learning algorithm that can be implemented in the regression. We have like let's say we can predict the distribution, we can have the Bayesian regression, linear regression, Bayesian linear regression, we have like decision support regression, like let's say neural network regression as well, and we have different type of algorithm we can implement it. And this is the cheat sheet actually, which is like it's gonna most of the time it help you. I'm being honest with you, like most of the time when I want to implement an machine learning, I directly actually refer to this cheat sheet, and by this actually it's gonna help me so much how I'm going to implement my data, how I'm going to implement like my algorithm in this part is based on what I need actually. And most of the things actually you're gonna see the data is gonna process either it's gonna be as a like numerical or like image. So you're gonna work actually with the image, which is like it's gonna be in the image classification. You're gonna go to the SetNet, which is like the modern deep learning algorithm. So you're gonna work with the deep learning or the network. It's up to you actually. What is the feature that you are going to extract from your algorithm? Another thing that I'm going to talk with you, which is like about the data analysis process. So the data analysis process is the first thing you have to do it, which is like define why you need to data analysis, and then being collection data from the source. As what I see actually, like most of the data that's being collected and prepared for you in the website. So you have actually, like let's say, the data set is ready, and you can work with that is very easily, and you can import it. And there is some type of the like project that I can see, which is like it can be like important to your code, whatever your code actually it can work. And the most important thing that you need to work actually, we call it like let's say the data cleansing or like cleaning through unnecessary data, which is like we need to like see what is the data that is not important for us and based on our requirement. And then you have to do many work actually with the data. I'm going to show you what is the data cleansing. And then the fourth thing we have like beginning with the analysis of the data, like what is the machine learning algorithm that you are going to use, and the fifth things, which is like interpret the result and apply them. So when you get the result, what you're gonna do actually with the result? This is the idea that you have to know actually. So we have different type actually by using like let's say the interpret and the result and apply them, such as we can do like let's say we can take the correct decision, we can do the data visualization on our data to represent what we are extracting and what we have learned from the like analyzing of the data to take the right decision. So so the data analysis, we have to know that it's like, let's say, defined as a process of cleaning, transforming, and modeling data to discover a useful information. That useful information, it helps us actually to take the right decision in the different field in our life, or in the business life, or in the marketing, or whatever the data that you are going to extract actually. So what we have to know now, I'm going to show you actually now. I'm going to like let's say give you the rest of the rest of the tools that we can use actually for the data analysis. You can see like here we have different type of the data analysis. We can use R programming language, which is like one of the robust and one of the good one of the good actually mechanism or tools which is using the R, which is like to be honest with you, it's like very solid in the statistical analysis, and which is like is very strong in that part. We have another thing we can use actually the Python. Python, if you are Python and R almost like let's say the same, But let's say Python, if you need to know like some programming language, because we have like a programming hackathon here, which is like I expect that you can use the Python as well. And we have like MATLAB, we have Java, we have SAS. Like let's say based on my experience, actually, I work with Java, MATLAB, Python. Uh, the MATLAB and Python, like they are almost the same, because there is like let's say many library you can import your algorithm, and always is up to date, and they are solid and like strong algorithms. And even though they are open source, like they give you a chance to improve the algorithm, and like based on what you are prefer. But in Java you need to, let's say, program most of the things actually from scratch, based on your preferences. But Java is more faster than like MATLAB and Python, and honestly, like it's fasting to get the result, is faster to be implemented. No, for implementation, the Python actually it's faster to run actually, and it can be implemented at most like the time. Okay, okay. If you do know actually like an coding language, there is like let's say different type of tools that you can use actually for like analysis, such as SPSS, and even though like the Excel, you can use it as well for like let's say for Excel to do like the analysis as well. But is my advice to you, if you learn Python, actually it's not that much complicated, it's very easy to learn. And nowadays it become like let's say number one, because everyone they can learn Python as well. So this is what is my advice. But there is, as what I remember, there is an SPSS, like even though you can use the Excel as well, and the SQL is as well. It can help you actually for data analysis. This is like let's say data analysis tools. Another tools that I can give it to you, I can show it to you actually here. We have like the data analysis process. Actually, what is the process? I think I mentioned the process actually before, but I use most of the time like this one. I repeat it actually many times, because it's gonna like direct you as a project, as well as a project leader, or as a project like let's say implementer. We can have like let's say the data requirement gathering, they already done for you. The data collection, they already done for you. What is you need to do, which is like data cleaning, data analysis, and data interpreting, and data visualization. So we have different, each one actually, each level of the data cleaning and data analysis and data interpretation and data visualization. We have actually different tools. Sometimes, like let's say, even in the Python, if you are using actually like for data cleaning, you are going to call another library for data analysis, and for the data interpretation, you need actually to call another library, and for data visualization, you need to call another library as well. So I'm going to show you actually like let's say for the data cleaning, you can use, look at here actually how is the process actually for data cleaning. We can like let's say identifying and deleting and duplicate data. So you need to know actually what is the data that you have it, and how you are going to read your data to check if there is any duplication. You need to delete it actually, because it's gonna affect your result in this case. And fixing an incomplete or like irrelevant data. Sometimes like let's say we can have data which is like let's say as it's incomplete. Like let's say there is some cell is empty, like they didn't fill it. Or like more example, there is, for example, we can have like irrelevant data which like does not have any relation with our data. Yeah, welcome Arin. Okay, another thing we can have like inserting missing details. So if we have like let's say some data which is like it's filled, we have actually two choices. Either we need to delete it, okay, or we need to fill it. Actually, how we can insert the missing details. Sometimes we're gonna use actually some mathematical model to insert it. Okay, and we have an auditing and aggregation actually. Like when we look at our data, we have to know actually Is it like it's need auditing, or it need, like, for example, aggregation? And usually most of the time, like for the auditing and aggregation, it's being used actually by using, for example, SQL, or like maybe it can be used actually by the, like let's say, by using the database. And matching and correlation. Sometimes we don't have, like let's say, an matching and correlation between the data. So we need to create an matching. We need to create a correlation between of them by adding some feature as well. We have like interlinking consolidation. Actually, for like interlinking consolidation, it's one of the part that you need to use it actually to, like let's say, to modify the data, such as, like for example, we have the data like male and female, and it will be presented in our data. It's gonna be F or M. So, and your code actually is gonna work with the numerical data, especially if you are work like with the supervised learning. So in this case, what you are going to do, you are going to work actually like to move it. Like for example, 1 is gonna be for male, and 2 is gonna be for female, for example. So those things, like, you need to understand it, how you're going to work with the data. So just, guys, actually, honestly, like all the participants, this is my advice to you. Before you work with the data, just you need to really look to the data and understand the data, and how you can, like, create a relationship between the feature, and like check the feature as well, which is like sometimes you need to identify as well, like let's say, the key variables. What is the, like, most important, like let's say, variables that it can be key for all the data. Like for example, in you as a participant, or like when we was in the university, we have like a student ID number, and this is going to be, like let's say, our key variable, for example. So we can use actually those things. And we have, like let's say, suggestion for the new variable. We can add a suggestion for the new variable to create a relation between, like let's say, two, like let's say, between to create a new feature between two feature as well. We have addresses the data, which is like synthesizing, we call it, when we are, like let's say, cleaning the data, and we make, like let's say, as a numerical, when we want to reduce, like let's, for example, the decimal point as well. And the last thing, which is like case correction, and, like let's say, convergence. Sometimes we can have like the data which, like, it's gonna be different from other data, then we need to work with that as well. Okay. For the data analysis, I can show you, like, here a list of the algorithm that you can implement it. We can use, like I said, the data analysis in the machine learning. We have the supervised learning, unsupervised learning, and we have the, let's say, the reinforcement learning. So we have to work actually what we are going to know, what we are going to do actually based on the cheat sheet, which, like I showed to you. We can use actually, like for example, in we have to do, like for example, if you need to classify your data, you make classification, like you classify your data. We have different types of classification. You can classify two classification or multi-classifying. You can use actually the regression. The regression most of the time it's gonna be used actually to make the comparison and to a prediction as well. And even thought, like for the clustering, we can have actually, like, if you need to make your data as a cluster, as a group, and work with them actually group by group. So by using, for example, classification, this one is gonna work actually with you very well, and you can extract a lot of information. So this is actually about, like let's say, the data you can work with as well. The last thing that I'm going to show to you actually, which is like, it's gonna be about the data analysis tool as well. We have NIME. Have you heard about NIME, R programming? This is the data analysis tool that when you ask me about, like, if you don't know about programming, actually, for example. So we can have, if you heard about, like this, the Rapid Miner. Have you heard about Rapid Miner? SAS, and we can have Tableau Public, NIME as well. R programming, this is for programming, Python, can be programming, Excel, Rapid Miner. It's help actually the most, let's say, to be honest with you, the most like let's say tools that can be help you so much actually if you are not a programmer. It's gonna be NIME and Rapid Miner. The Rapid Miner and NIME, they are the most two popular tools that being used. But actually the problem with that, it's paid. Like you need to use like let's say you should have an like a license for that based on the NIME and Rapid and SAS as well, I think so. And Tableau, it's Tableau Public as well, it's working. And if you hear about like the Microsoft Power BI, it's working as well for data analysis tool. So, but it's a little bit complicated. But the nice thing with the Microsoft Power BI, because most of our work actually it's based on the Microsoft, like let's say, products such as the Microsoft Office or like Excel, Access. So it's easy for them actually to import it. But I even thought like it's easy to import it for 9 and RapidMiner. Apache Spark, it's as programming. IBM SPSS modular, if you heard about this one, which like being used actually for analyzing the data. Last things actually, which is like it's gonna help you for visualization. What we mean actually by visualization, we need actually like let's say some types of like to show the data. We don't like to see numbers actually in front of us. No one like to see numbers. Like when you are creating your project, you want to submit your project, no one like to see numbers. Most of us actually we like to see graphs. So how you gonna use actually, let's say you can have actually a very amazing nice graph, like different type of colors, like different type of like let's say of graphs as well. We can have actually different type of, like as I showed to you, there is a lot of data visualization tool that can you see. We can start actually from lower, which is like the people who don't like to program, and to the higher, the people who would like to insert the data by programming and something like that. So you can see like we have in the Excel, we have like Vislo, we have like let's say Infigure AM, we have like let's say data wrapper as well. All that and Power BI, the people who don't know, who don't like how to program. And then to be honest with you, actually, among of those, which is like among of those like tools, the best tool you can find, or I recommend tool, which is like a Click and Tableau, a Click and Tableau and Plotly. Those actually, which is like you need to learn just a little bit of coding, which is like you need to understand how is the importing the data. That's it, not that much. And just you need to work actually with a Tableau, okay, and let's say Click as well, and the Plotly. I recommend actually those three, because I most of the time actually I used to work actually with the raw graph AI. Power BI from Microsoft is very nice, but let's say the Tableau is it's been built actually, or been created for image, for visualization, like which is like it can expressing your data with the very nice amazing graphics as well. So that's what I wanna just share with you today, and which like it's gonna help you. And thank you so much. And if you have any question, just go ahead, guys.
Thank you, Dr. Hamza, for that great presentation. And
most welcome.
Thank you. I think if we had any question, you can type it in the Q&A session, or you can type it in the chat. The chat now is available. See if we have any question. For all the attendees, or if you have any question, please type it for Dr. Hamza in the Q&A section, or you can write your hand also if you want to speak with Dr. Hamza.
Yeah, Tableau, it's a free software. And one more thing, it's you can find a lot of tutorials that help you how to use it, and it's not that much like complicated. And one more thing, if just to tell you actually about like one software for data analysis for the, when I see actually like let's say some comments on the chat, I saw like some people are worried actually about the coding part. Okay, in one of the like let's say one of the tools that I propose here, or I showed you, which is like called like RapidMiner. RapidMiner is very simple application that's being used, okay, and honestly you are not going to face a lot. And one more thing with the RapidMiner, with the rapid miner company, actually, they already have a class on the YouTube. There is, I think, 12 or 12 hours of a class how to use the rapid miner from A to Z until you become professional on that. So the rapid miner, it can be like, let's say, and a good solution for you, for the people who don't know how to code. Any question
I think we had another question, Dr. Hamza.
on the
What,
chat?
yeah, what are the challenges that need the data analysis?
Okay, to be honest with you, actually, based on my experience, actually, the most challenge most of the time, actually, we are faced while we are analyzing the data, which is like the data cleansing, which is like cleaning the data, because to, like, let's say, like we are like spend, like, let's say, 40% of our time just cleaning the data, which is like preparing our data. This is like the most challenging. So if you understand how to analyze that, how to like clean the data, what is you need from your data, and to understand to clean the data, you should understand the data first. You should know what you need from the data first, and then you can analyze your data. So analyzing the data is not that much complicated, because as what you see, there is a lot of tools that help you to analyze the data, and this, it will not take time actually from you. But as what I said, 40% of our time, it's gonna be person, it's gonna be like spent on the cleaning that data. Any question?
I think that there is another question related to the previous one. What are the challenges that doesn't require the experience of data analysis?
And let's say most of them, it needs some practical, I will not call it experience. You need like to practice, because you need to learn from your mistake. Like you're gonna see some mistake, you need to learn from your mistake. You need to search about this one. There's nothing actually is not easy, especially like in the data analysis. That's why actually like the data analyst actually in some organization, they paid high salary actually. That's why you need some practical on that.
Sure. Yeah, they are very high salary in some
Yeah.
organizations. Yeah. I think another question in Q&A, there is a free version. I think he asking for the tools for the data analysis.
Which tools actually like for the free version?
He's asking Arhan if you require to make your question clear, please. You can type a new question with clear. He's typing there is a free version. I don't know which is.
Yeah, Arhan, can you repeat your question actually? Which tools you want it to be free actually? Tableau. Yeah, I think, yeah, there is a free version in Tableau actually. I think so. But I used the paid one. I used the paid one actually. But I think it's very easy to use it, and there is a free version of that. Yeah, for Tableau.
I think there is another question in the chat, Dr. Hamza.
Yeah, there is. How can I interpret some data from the okay, if you want to interpret actually the seismic data from the Moonquick map, the first thing that the challenge that you are going to face actually, which is like, since the map is not very clear, and let's say the radio frequency is not that much clear, so you need actually like to clean the data, which is like to remove the like, let's say, we call it the data, the noisy data, the noise data actually. So if you clear the noise data, again, it become like, for you, it's easy to understand if there is an harmonic quick map challenge, like then you can analyze it, that data. And most of the time, what do you need actually from the like from the Monocut map data, so from the Monocut data, actually, what you need actually from that data. So the most important things that what you need actually from that data. This is the how you're gonna like, let's say, analyze your data.
I think most of that, all of the questions. If you had another questions, please type it in the Q&A or chat. We would like to thank you again, Dr. Hamza, and we
Most
hope to
welcome.
see you in Dubai University, inshallah, in 1st and 2nd of October.
Inshallah. Okay, inshallah. Thank you so much. And
Thank you.
feel free to contact me, guys, if you need any help.
Sure. Thank you, Doctor.
Okay, most welcome. Okay. Thank you so much.